Hello Year 10 5.3 Mathematics students. Today we are continuing on with the topic of probability and we are learning about two-way tables. So like Venn diagrams, two-way tables are useful tools for the organisation of overlapping events. The totals at the end of each column and row help to find the unknown numbers required to solve various problems. Two-way tables use rows and columns to describe the number of elements in different regions of overlapping events. So what we have here is we have a Venn diagram, which we looked at last lesson, and we also have a two-way table. And we're going to have a little look at how they are the same. So our first thing that we have is we have our number 4 here. You can see that this is A and B on our two-way table. On our Venn diagram, our number 4 is this overlapping section where A and B both occur. We then have A not B, which is this side, which is this number of 10, which means A only. So if we look at our Venn diagram, our A only is this section here, which is also got the same number of 10. Our B only, which is B not A, is the number 6, which is this section here on our Venn diagram. And so that means that it's only the parts of B. And finally, our 3 here is this number 3 on our Venn diagram, which means neither A nor B. We then also have these totals. So we have our total for B, our total for not B, which is 10 and 13, and they add up to 23. Then we have our total for A and our total for not A, and they are 14 and 9, which also add up to 23. So you can see here that the total for A and the total for not A must add up to 23, and the total for B and the total for not B must add up to 23. So when you only have different parts, you can use this total to help you find the missing pieces of your two-way table. Moving on to an example. We have this Venn diagram and two-way table which shows the types of computers owned by 100 people. So we have Macs and PCs. So how many people were surveyed? Well, if we look at our two-way table, we can see here that this total of 100 is the total amount of people that were surveyed. So 100 people were in fact surveyed. Then we want to know for part B, how many people own both a Mac and a PC. So if we were to look up at our Venn diagram, so our Mac and our PC is, when we look at our Venn diagram, it is the overlapping section here of a 12. And when we look at our two-way table, it is the row of PC and the column of Mac. So that means that we have 12 people own both a Mac and a PC. Then we want to know how many people own only a PC. So if they were to own only a PC, that would be that we'd have a PC and no Mac. So that's going to be this part here. So just the PC. So that is 50 people on our Venn diagram. And on our two-way table, it is also 50 people. So only a PC is 50 people. Then we want to know how many people do not own a Mac. So that is the total of people that do not own a Mac. So that is going to be no Mac, the total of no Mac. So that means that it will be this 57 here. So the people that don't own a Mac is 57 people. Because out of those 57 people, they might own a PC or they might own no computer at all. And how many people own neither a Mac or a PC is this part here, this number 7, which is down here. So own neither a Mac or a PC is going to be 7 people. They own neither those types of computers. Okay, moving on to example 2. We have the Venn diagram shows the distribution of elements in two sets A and B. What we want to do is transfer the information in the Venn diagram to the two-way table. So what we're going to have to do first is work out how many are for A and B. So that is this middle section here. So that is this middle section here, which is 1. So that means that one person is in A and B. Then we want to look at A not B. So A not B is this part here, and that is 2 people. So A not B is 2. For the B not A, that is this section here, this yellow section, and that is 6 people. So B not A. And then for our not B not A, that is the 3 people out there. So then we want to make sure we're right. So our column total of A is 1 plus 2, which is 3. Our total of not A is 6 plus 3, which is 9. Our total of B is 7. Our total of not B is 5. So then 7 plus 5 is 12. 3 plus 9 is also 12. So 12 goes in our total box here. Part B says find the number of elements for these regions. So A and B. So that's in both A and B. So that's our overlapping section, our light blue section there, which is 1. So that equals 1. For B only, so only B, that would be the B not A, so that will be 6. For A only, that will be A not B, so that is 2. For neither A nor B, that will be 3. For all of A, that will be the total of the A column, so that is 3. For not B, that will be the total of the not B row, which is 5. And for A or B, that is going to be our B, so it's going to be our B A, so our 1, plus our B not A, which is 6, plus our A not B, which is 2, so that equals 9. Okay. Finally, we want to find the probability of A and B. So what we need to do is for A and B, if we look back, that was a 1 over our total of 12. So our probability is 1 over 12. The probability of not A is going to be the total of the not A column, which is 9, over our total of everything, which is 12. So 9 over 12 is 3 over 4. And the probability of A only is going to be the 2. So A only is A, not B. So that's 2 over our 12. And that equals 1 over 6. Moving on to example 3, we have at a car yard, 24 cars are tested for fuel economy. 18 of these cars run on petrol, 8 run on gas, and 3 cars run on both petrol and gas. We want to illustrate this in our two-way table. So what we need to do to start off with is we need to put this information into our two-way table. So we have 24 cars tested in total. So that means our total here is going to be 24. We're going to leave the 18. So 18 of the cars run on petrol. So we're going to say, we're going to let A equal petrol and B equal gas. So A equals petrol. So that means the total of petrol is going to be 18. So then we know that 8 cars run on gas, so the total of B is going to be 8. And we know that 3 cars run on both petrol and gas, so A and B is going to be 3. Now we need to find the rest of the information. So we know that the row of B must add to 8. So that means 3 plus something equals 8. So we're going to make that a 5 because 3 plus 5 equals 8. We then know for our column of A that 3 plus something must equal 18. So that means that must be a 15. We know that our 18, this row here, our 18 plus something must equal 24. So if we go 24 minus 18, we get 6. And we know that our 8 plus something must equal 24. So if we go 24 minus 8, we get 16. And then based on that information, we can find what our not A, not B is by going 16 minus 15 is 1, and 6 minus 5 is also 1. So that means our not A, not B must be 1. And so that is how you fill in your two-way table based on that information that we've been given. Now we want to answer how many of the cars do not run on gas. So remember, gas is B. So how many cars are not gas? So that is our 16. How many run on neither petrol nor gas? So that's neither of both. So that is 1. Now we want to find the probability that a randomly selected car runs on gas. So remember, gas is B. So the total of B is, so probability of gas. So that's going to be 8 over 24, which equals 1 over 3. And then we want to find the probability of only gas. So that would be gas, not petrol. So gas, not petrol is 5 over 24. Where 5 over 24 simplifies down to nothing. So it's just 5 over 24. And then we want to find the probability that it runs on gas or petrol. So what we have to do here is we have to add up that it can run on both. So 3 plus it could run on 5. So it could run on gas but not petrol. So that's 5. Plus it could run on petrol but not gas, which is 15. All over our total of 24. So 3 plus 5 plus 15 equals 23 over 24. And that is it for our two-way tables.